Hey guys, today we'll be doing a really simple and easy to score topic, logic gates. And I have here some pre-made handwritten notes just to save some time. So apologies for bad handwriting. So starting off right from the basics, what are logic gates? Logic gates are simple input-output performing operations. They take in certain input and give you a certain output. Now, what are the inputs that a logic gate takes? Since logic gates are mini gates or individual gates installed in your computer, they obviously use the binary language. And binary language consists of your 0 and 1. Your inputs can be 0 or 1, or they can be both 0 and 1. But your output is always either 0 or a 1. Now, what does that mean? Let's understand in detail later, but for now you have to just know that binary input numbers are 0 1 and output is also 0 1 because you're performing your operations are binary numbers. Your output is also a binary digit. Now, looking at what possible combinations are. Before looking at the possible combination ka formula, let's look at the type of gates that are available. So we have your NOT gate, AND gate, OR gate, NAND, XOR, NOR gate. Now, NOT gate is the really simple and basic gate, but it is also an exception to all the other five gates. The NOT gate is the only gate that takes only one input. All the other five gates can take two or more inputs. How do you determine the number of combinations that are possible? That is, of course, whatever your gate is, your input is either a 0 or 1 always. So the number of inputs that you're giving in is either 1, 2, or more. Is either 1, 2, or more. What does that mean is, if you're, say for example, I'm giving two inputs, so 2 part 2, 4 is the possible number of combinations in which I can arrange my zeros and ones. The possible number of ways in which I can arrange my zeros and ones and perform this particular operation, whether it's not, whether it's and, whether it's or, and so, is determined by this formula 2 par x. So if it is 2 part 2, say it's 2 part 2, then the number of possible combinations would be 2 bar 2, that is 4 number of possible combinations. If it is, say, just one input that you're giving, for instance in NOT gate, as I said, only one input can be taken in. The number of possible combinations of the zeros and ones would be 2 par 1, so hence only two possible combinations of 0 and 1 can be taken. Whereas for all the other gates, if you're taking two inputs, 2 bar 2, four possible combinations of 0 and 1 are possible. Next, looking at truth table. Now, this kind of messy. Let's simplify it. Truth table is a way of checking the or tracing the output from a logic circuit. Now, again, what is a logic circuit? All we learned was about logic gates. Now, logic circuit is a mixture of all logic gates. You combine various logic gates to obtain a logic circuit which performs a specific output, like one gate after the other. You're going to combine and get a end output. First, there are like three simple steps to draw a truth table. First, check the number of inputs that you're giving. So this is the formula that we saw 2 par x, where x is the number of inputs that is going on, whether 1, 2, or more inputs that you're giving on. One input is only possible in the case of NOT gate as seen. So calculate the number of possible combinations of zeros and ones. So what would be the possible number of combinations of zeros and ones is determined by 2 power x, where x is your number of inputs. After calculating this, you have to draw your truth table. In your truth table, we have these two segregated sections. So A, B are your inputs, whereas X is your output. So you have to memorize this input, which is pretty simple. These are the possible number of combinations. So A would be 0011. This is the truth table when you are giving only two inputs. We can have more than two inputs or just one input in case of NOT gate. I'm keeping on repeating, NOT gate only has one possible input. So when you're giving two inputs, you have 0 0 0 1 1 0 0 1 1. So you can memorize this like 0011. That's how your A column goes. And your input B column goes 0101, right? And X is the output that you're obtaining by performing your binary logic gate operation on your these two inputs. So if you're performing a NOT gate operator, NOT gate ke liye there's a separate truth table. We are going to look at that later. So say instance you are doing or an and, and operation. चलो and operation लेते हैं. So and operation को you're gonna perform on these two and obtain an output, that is your x. So your first type of gate is your NOT gate. The NOT gate is also known as the inverter gate. Now, when you're putting a NOT gate in into like a circuit form that is inside your logic gate, you will need a specific symbol to denote your NOT gate. So this is the symbol that you use for your NOT gate. A is the input that you're giving. Now, a NOT gate only takes in a single input. In this case, let's say A is our input. So it's taking either 0 or a 1. Since it's a single input at a time, it can only take either a 0 once or a 1. So what the NOT gate does is it inverts your input. So if your input is 1, the NOT gate would make it a 0. But if your input is 0, it would make it a 1. Since only one input is taken, so 2 power x, 2 power 1 possible number of combinations are possible. That is 2 possible number of combinations are possible. So in your truth table, A is your input, X is your output. 0 and 1 are the only possible inputs that you can give. And X is the output that you're giving. So 0 would become 1 and 1 would become 0. Now, the logic notation for this is you would write not A. That is not 0. So if not 0, then it would be 1. If not 1, it would be 0. Right. Now, let us also understand what Boolean algebra, how it would be written. So, A is your output and you're writing a dash above your A. So, A naught. You read this as not A or A naught. It would invert your input A. You can also understand this as output X is 1. This output is 1 if your input A is not 1. The next type of gate is your AND gate. AND gate is again simple. This is the symbol for your AND gate. AND gate, unlike NOT gate, all the other gates that we'll be looking on from now on will take more than one input. So it can be either two or three inputs. In that case, your inputs will change. So that you have to memorize anyways from your notebook, because if you sit in your exam hall and try out the possible number of combinations for zeros and ones, it's going to take you an eternity. So as seen, the possible number of A would be, the A column would be 0, 0, 1, 1, B column would be 0, 1, 0, 1. This stays constant for any logic gate with two inputs. So memorize this part. What the AND gate does is it multiplies your operators, A dot B. So it's like simple maths. You do 0 into 0, you get 0, 0 into 1, 0, 0, 1 into 0, 0, 1 into 1, 1. What we are observing is your output X is only 1 when your both inputs A and B are 1. But if both are 0, then you'd get 0. If one of them is 1, you would get anyway 0. Only if both are 1, you would get your output X as 1. The logic notation is X equals A and B. In Boolean algebra, you would write A dot B. The dot operator means multiplication. You're multiplying A and B. The word and signifies that you're multiplying it. What are you multiplying? Your inputs. That is A and B. You're performing the AND operator on your inputs A and B. Also, don't forget to check your possible number of combinations. Since you're giving two inputs, you would be 2 power x, which is 2 power 2. So, four possible number of combinations. So, we have 1, 2, 3, 4 possible number of combinations of your zeros and ones. That's 0, 0, 0, 1, 1, 0, 1, 1. Next type of gate. The third type of gate is the OR gate. This is also simple. Again, it takes in two inputs A and B and gives you a specific output X. The possible number of combinations would be 2 power 2, that is 4 possible combinations. Now, your truth table would be, again, since only two inputs are there, you would be having this simple number of combinations that you have to memorize this. 0, 0, 1, 1, 0, 1, 0, 1, and your X. What OR gate does it? It adds. It adds 0, 0, you would get 0. Now, when you add 0, 1 in simple math, it would be 1. When you add 1 and 0 also, it would be 1. Now, the only exception is in your binary addition, when you add 1 and 1, it wouldn't be 2. Either, even though it is 2, you have to just, understand that when 1 and 1 are added for your logic gates, your output would be 1. How it would be 1, I'm going to put it in another video. That's binary addition, not necessary. Just know that when you're adding 1 and 1, your answer would be 1. So the logic notation is A or B.
and your Boolean algebra, you're gonna write A plus B. So in OR gate, what is happening is output X. Your output X is 1 if your input A is 1 or input B is 1. Either of your inputs should be 1 to make your output X. Even if both are 1, your output would be 1. Even if either one of your inputs is 1, your output would be 1. So this is a simple logic gate. Instead of memorizing the output, you just need to know what is happening in order to do it in the exam. So you're just simplifying the process and understanding what's happening. The next type of gate is the NAND gate. A NAND gate is a combination of a NOT and gate. So you're combining and NOT. So what NAND gate does is it inverts the operation that AND gate is performing. So AND gate is going to multiply A and B, whereas the NOT gate that you're putting over here is going to invert it. Whatever output you're getting over here, the NOT gate would invert it. So this is the symbol. A and B are your two inputs, and this is the NOT. So this symbol is like you're drawing an AND gate, and you're putting a dot circle to simplify your NOT gate. Instead of putting a triangle and a circle, you're simply putting a circle in front of your AND gate to show that it's a NOT gate. So again, 2 part 2, 4 possible combinations are possible, and this is your truth table: 0011, 0100, sorry, 0101. So these are your possible number of combinations of zeros and ones. X क्या करेगा? अब A and B are first being multiplied. So 0 into 1. That's what AND gate does. AND gate multiplies A and B. So 0 into 0 is 0. But since we have an AND NOT gate in front of your AND gate, this is going to be inverted. So 0 into 0 is 0, but your NOT gate would make it a 1. 0 into 1 is 1. Sorry, 0 into 1 is 0, but your NOT gate would make it a 1. 1 into 0 is 0, but your NOT gate would make it a 1. 1 into 1 is 1, but your NOT gate would make it a 0. So your the output X is 1 if input A is not 1 or input B is not 1. So either of your input should not be 1. You get that? And this is your Boolean algebra A dot B, and you put a not operator in front above A dot B. So A and B is your logic notation, A dot B not is your Boolean algebra. So while writing in Boolean algebra, you write A dot B not. And this is your truth table for your NAND gate. So just know the logic behind what is actually happening. You're first multiplying and then you're inverting whatever answer you're getting. Next, you have the NOR gate. NOR gate is a combination of NOT and OR gate. So you first draw your OR gate and you put a circle instead of drawing entire triangle and a circle to show NOT gate. You simply put a circle in front of your OR gate. So again, two outputs A and B, and X is your output that you're getting. So OR gate mein you're gonna add 0 and 0. So 0 plus 0 would be 0, but this NOT gate in front of your OR gate would make it a 1. So 0 plus 0 is 0, but NOT would make it 1. 0 plus 1 is 1, but OR would make, NOT would make it 0. 1 plus 0 is 0, but it would be, 1 plus 0 is 1, but X would be 0 since you have a NOT gate in front of it. 1 plus 1 is 1, but NOT gate would make it a 0. सो और का जो भी ट्रूथ टेबल है उसको आप इन्वर्ट कर रहे हो टू गेट नॉर गेट यू आर सिंपली इन्वर्टिंग whatever output you are getting by OR gate. So your Boolean algebra would be A plus B not. Logic notation में you're gonna write A nor B simply, but in your Boolean algebra you'll get A plus B not. So A plus B जो भी आप कर रहे हो उसका not होगा NOR gate. Next you have your XOR gate, the difficult type of gate. Actually I'm going to simplify it for you. XOR gate में again you're gonna take A and B as your inputs. XOR is also known as exclusive OR in some of your textbooks. It's going to take two possible inputs, so 2 part 2, 4 possible combinations again, 0011, 0101, A, B are your inputs, X is your output. Now, यहाँ पे अब what exactly you're doing is, you better like memorize this one particular gate, or you can understand the logic behind it, what exactly is happening is if your input A is 1 and your input B is 0, or if your input A is 0 or your input B is 0, your input output X would be 1. You should have opposite inputs to get your output x as 1. So this is how it works. You write in your logic notation as A, X, or B. So this is a huge operation that you're performing. Unlike and or gates, यहाँ पे you have to do a big calculation. पहले A को आप लोगे multiply it with B naught and added with A naught with B. So ये आप समझ गए होंगे. I expect you to understand it. So instead of learning this, you can also write it in Boolean algebra like this. But this is the simpler way. This first one is your simpler way. So learn this for your Boolean algebra notation, and this is your XOR gate, simplified. So that's it for today's video.
Please like, share, and subscribe. And if you need any other videos on any other topic, please do comment it down. Thank you.